Hi everybody, uh, myself Muhammad Ismail. I am assistant professor in the Department of Electronics and Communication Engineering. Today we are going to discuss about the topic common emitter configuration. So this is very important topic. As far as this common emitter configuration is concerned, so it is going to characteristics that transistor characteristics in terms of common emitter. Right. So before getting into this topic, first of all, we have to know the basic concept about the transistor. So we are going to discuss about the basic concept about transistor. So regarding the transistor, transistor is an three-terminal device, namely collector, base, and then emitter. So and also one of the main thing in a transistor is an bipolar junction. That's why it is called as an BJT, bipolar junction transistor. So these transistors are mainly used as an amplifier and switches. Because to amplify any signal, we have to use basic components like transistor. It is going to amplify the signal. That is weak signal is going to be amplified with the help of this transistor. As far as the types is concerned, BJT is of two types, PNP and then NPN transistor. So based on these types, the transistor terminals will be described. Let us see how these terminals are to be described in terms of PNP and then NPN transistor. So as far as this PNP transistor is concerned, so collector is connected to the P type, and then base is connected to the N type, and then emitter is connected to the P type. So this is the PNP transistor construction. And while going for the NPN transistor, so this in NPN transistor, N type is connected to the collector, and then P type is connected to the base, and then N type is connected to the emitter. So these are the configurations of this PNP and then NPN transistor. Next we move on to the symbol of this PNP and then transistor. So this is a variation in PNP and then NPN transistor. So these are the basic concept about the transistor. Now we are going to the main topic called common emitter connections or common emitter configuration. So why the name common emitter is termed means the emitter is common to both the collector and then base. That's why it is called as a common emitter configuration. It means emitter is connected to both the base and then collector. See the circuit diagram shows that here emitter is connected between the base and then collector. So that's why it is called as a common emitter configuration. So in this circuit we are analyzing the input and then output characteristics. So input, let us see the input. Input is taken, input is applied between the base and then emitter, and output is taken across the collector and then emitter. So emitter is common to both the input and then as well as the output characteristics. So now let's see how the input and output characteristics of this common emitter configuration be derived. So this is the main characteristics diagram of an common emitter configuration. So here we are using some ammeters to measure the current, base current and collector current, and then we are using voltmeter to measure the base emitter voltage and then collector emitter voltage. So let us see how this current and then voltage can be derived from the characteristics. So this is the input characteristics. So input characteristics, it is a curve between the base current and then base emitter voltage, keeping collector emitter voltage constant. So in this input characteristics, we are keeping voltage collector emitter voltage as a constant one. With that constant, we are going to measure the base current and then base emitter voltage. See in this graph we are seeing that VCE equal to 10 volt. By keeping VCE equal to 10 volt constant, so we are going to vary the we are going to vary the base current and then base emitter voltage, and then we are taking the reading between the base current and then base emitter voltage. Okay, so this is the input characteristics. While going for the output characteristics, so in output characteristics, we are keeping a base current as constant, and then we are going to measure the collector current and then collector emitter voltage. So this graph shows that the base current will be kept constant with 5 microamps. So we are keeping base current in 5 microamps as a constant current, and then by varying the voltmeter and then ammeter reading of this collector and then collector and then collector emitter voltage, and measuring the collector current and then collector emitter voltage by keeping this base current as constant. Yes, if we do like this, we can finally obtain the characteristics of an input and then output characteristics. And one more thing is here this value of VC will be based upon the collector current. Once the collector current is changes, the output of this VC will get changed. So thus this means that collector current which changes with the collector emitter voltage is called as an knee voltage. So these are the main thing we are going to discuss in this topic. So once again I am remembering all those things. In collector emitter configuration, we are going to see in the input characteristics and then output characteristics. Input characteristics is nothing but in input characteristics we are going to measure the parameters of base current and then base emitter voltage by keeping the collector emitter voltage constant. And in output characteristics we are going to measure the collector current and then collector emitter voltage by keeping base current as constant. Okay, so this is the configuration of common emitter configuration. And in one more thing, there is a three regions will be presented in this transistor. There is a cutoff region, saturation region, and then one more region. There is the main thing in this common emitter configuration. Thank you so much.